Thank you. It's a +1 for you for always reminding me. Let's start on the first example and see if we could do these. As I said, I find of all the things that we do this term, the whole manipulation of these rational expressions, or these fractions, is probably one of the hardest things to do because there's so many steps involved. And just like people don't like regular fractions, they're just not so easy to work with. It's true about these rational expressions as well. So if you remember, the first thing we had done on Tuesday is we had combined, added, and subtracted fractions, and then we talked about solving equations that had fractions. Again, probably I'm going to concentrate more on this solution. It's very important to be able to solve the equation that has fractions in it. Before I even start that, let me remind you, today is midterm day. That means starting at 2 o'clock, the midterm is going to be available on your Blackboard account. There's a separate section in Math 136 that says midterm. You just click on it and your midterm, it's not going to be available until 2 o'clock, but from 2 o'clock until 4 o'clock on Friday, it is going to be available. Make sure you do it in that period. If you have some problem that you cannot do it because you have something going on, either from this afternoon till tomorrow afternoon, you have to send me an email as quickly as possible so that I can arrange a separate time for you to take that exam. But this is when the midterm is going to be available. Again, it's 20 questions. It's 20 multiple choice questions, very similar to the test 1 on Blackboard that I gave you. Okay, let's look at this problem now. As again, these topics are not part of the midterm. Unless I'll give some time at the end of the period if anybody has anything specific that they'd like me to review for the midterm, but looking at the results of test 1, most people did quite nicely on it. So I feel that you're sufficiently prepared for the midterm. Okay, so looking at this first example, we have 2 fractions. One has a denominator of x plus 2, one has a denominator of x plus 3. Now remember, the first step in adding or subtracting fractions is to find what we call the LCD, the lowest common denominator. And we do it by first factoring our denominator as much as we can. And there's nothing to factor here. These are as simple as they can be. They can't be simplified any further. And then we go to our first fraction, circle all the factors of that in that first fraction, which is just the x plus 2. Then go to your second fraction and circle anything that hasn't been circled before. Now, x plus 3 has not been circled before. The only thing that's been circled is x plus 2. So I've got to circle that as well. And if I put all these circled factors together, which is going to be the x plus 2 and the x plus 3, that is going to be our common denominator. So we're now going to take each of these fractions and rename them. We're going to do that by dividing the original denominator, which let's say in this case it's x plus 2, into the x plus 2, x plus 3. Obviously, the x plus 2 gets canceled out. So what I'm left with is x plus 3. That's what I have to multiply this numerator by. In other words, I'm going to have to take this 5x and multiply it by x plus 3. In other words, I put an x plus 3 in the bottom, I've got to put the same x plus 3 on the top to keep the fraction the same value. Going to the second fraction, I have an x plus 3 here, so that's this. What I don't have is an x plus 2. So I have to take this 8x and multiply it by the x plus 2 in order to keep the second fraction the same value. Now, once I have a common denominator, then we just, for the meantime, just work with the numerators. Let me go over here. I'm going from here. So what are my numerators? My numerator is the 5x times x plus 3, which is going to be 5x squared plus, you know what, let me rewrite this. So I'll have it right in front of me. So here's what I have. I have 5x times x plus 3. I'm just writing the numerators over. Minus 8x times the x plus 2. And what I have to do is I have to combine all these terms and then put it over the common denominator. So this is going to give me 5x squared plus 15x. I'm removing the parentheses using the distributive property. And this is a negative 8x times x, which is negative 8x squared, and negative 8x times 2, which is negative 16x. Okay, combining these, the 5x squared and the negative 8x squared give me negative 3x squared. The 15x minus the 16x gives me minus 1x, or just minus x. And all that is over x plus 2 times x plus 3. Once I've combined all the like terms, I put it over the denominator. If you notice, the numerator could have been factored by a negative 1x or a negative x. So I could have also written, I notice I'm using a negative because the leading coefficient is negative. If I take out a negative x, I'll get 3x, and negative x into negative x is plus 1. And that's all over the x plus 2 times the x plus 3. And either one of these answers, this one or this one, are good answers. As I said, a lot of steps. Sometimes we see, once we factor, remember, we'll have our denominators already factored. If you factor the numerators, sometimes you can reduce it. Sometimes, in this case, we couldn't, but sometimes you can. So that's how we deal with adding and subtracting of fractions. We find our common denominator and then work with the numerators, simplifying our numerator as much as possible, and then put it over the denominator. Don't forget to put it over the denominator in the end. Don't just leave this answer. You have to put it over. I know we don't have to work with it, but the final answer has to be over the denominator. Okay, the second thing we talked about on Tuesday was solving what we called rational equations that have fractions in them. And just like we did with adding and subtracting, in order to solve these, we have to find a common denominator. Now, in this case, my denominators are all what we call monomials, single terms. So if you remember, when finding the common denominator, all you have to do is take the numbers, which are 2, here there's understood 1 and 4. So that'll be the common denominator of those, that is going to be 4. And when you have the letters, you just take the largest exponent, and the largest exponent we have of all these letters happens to be x. So my common denominator, I think everybody can look at it and see that my common denominator is 4x. You put the common denominator over 1. You take your LCD that you figured out, put it over 1, and multiply your whole equation by that common denominator. The purpose in doing this is so that we can have an equation that doesn't have any fractions in it. Let me get a better marker. Let's see if this one will work. Oh, this is certainly not going to work better. Okay, now when we're multiplying something by the whole equation, we have to use the distribute property. So let's just write it out. We're going to have to take the 4x over 1 and multiply it by the 5 over the 2x. And we're going to go to the equal sign, and we're going to take the 4x over 1 and multiply it by 1 over x, and also the 4x over the 1 times 3 over 4. Basically, we multiplying by our common denominator. Since I'm multiplying both sides of the equation by the same thing, I'm not changing the answers to my equation, and that's what I'm looking for. The answer is the solution. And once I'm multiplying, I have to use the distributive property. And now do the multiplication of each fraction. Now, the way I've set it up, each denominator that we have should cancel out. Over here, I have a 2. It's going to cancel into the 4 and give me a 2. And the x will cancel out totally with the x. It should work out in each fraction that we end up with a 1 in the denominator. Notice that means I'm left with a 2 times 5 in the numerator, and since my denominator is 1, I can just write it as 10. Now I go to my equal sign. Now I have this 4x over 1 times 1 over x. Here, the x will cancel out into the x. This will leave me 1. This will leave me my 4. Don't forget, you're not subtracting, you're dividing. And 4x divided by x gives me 4. So now I will multiply the 4 times 1, which will give me 4. The denominator again has to be 1. By using the common denominator, I'm forcing this to happen, that all my denominators will turn out to be 1. In my next fraction, I have the 4 in the denominator. will cancel out into the 4 in the numerator and just leave me an x. So now I'll have x times 3, which is 3x. And look what I've accomplished. It's a lot of work, but now all I have is an equation without any fractions. This is an easy equation to solve. All I have to do is subtract 4 from both sides. This will give me 6 equals 3x. And if I go over here, divide both sides by 3, and I'll get 2 equal to x, or my answer is 2. So we do a lot of prep work by finding this common denominator and multiplying by that common denominator, but the result of that is that we end up with a very simple equation to solve at the end. Okay, so that's pretty much where we had been on Tuesday. I want to do one more example with you on these rational expressions before I give you one to try. Okay, don't forget, I'll say it again a few times, the midterm is going to be available today starting at 2 p.m. and continuing. It'll be available until Friday, that's tomorrow, at 4 p.m. Pick a time in that so that you can be finished on time. You have a total of 75 minutes. I don't think you need more than that. I don't even think you need the whole 75 minutes. I think most people have no problem with that. It's again 20 multiple choice questions. You have to do it all at one sitting. Let me also remind you, because this happened to a few people while they were taking that first test on Blackboard. If you get bumped off of your internet, or for some reason the test closes early and you weren't completed with it, send me an email. Let me know that you're having a problem. What I can do is reset the whole test for you. I can't reset part of the test. This is either I can accept the test answer, but if you got a 20 because you only got the first four questions, and then somehow you got bumped off your internet and the test will automatically submit, obviously you're not going to be happy with that mark. So if you're not happy with the mark because you didn't have time to finish, because you had technical difficulties, send me an email. Now, if you're taking this test at 2 o'clock in the morning, I'm not going to see that email until the following morning. I check my emails regularly, but I don't check them every 5 minutes. So I will check it. If I see I get an email from you, I will reset your test if you want that. So if you're emailing me, keep in mind, the only thing I can do is reset the whole test, which means you're going to have to start from scratch, which also tells you you really should leave yourself enough time to accommodate the possibility that you might have a glitch with your internet. Again, if it happens and you're at the end of the time period, I can reset it for you, but that takes a lot of effort on my part. It's not something I prefer doing. I prefer you sit down and do it as early as possible to avoid any possibilities. But this is the midterm. Again, what we're doing today is not part of the midterm. So we're going to do another one of these rational equations. I'll do one with you, and then I'll give you time to do one on your own. let's say I gave you this equation. X over x minus 2 plus 2/3 equals 2 over x minus 2. Again, we'll know it's a equation because we have this equal sign in it. We'll also know it's an equation because the instructions will be solve or find the solution or answer this. But basically, when you have an equal sign somewhere in the middle, then that's an equation. If you don't have any equal sign in it, it's just then all they want you to do is, as they say, perform the operation or just do the problem. But this is an equation, which means we have to get a value for x. Let me also remind you that if you have fractions and there's a whole number, let's say this would have been only a 2, I would have right away put the 2 over 1 so that I could look at everything as if they were fractions. Now remember what we said we're going to do. To solve this, the first thing we're going to do is to try to find the least common denominator. And that means, since I see polynomials, that I have to factor. But these are not, there's nothing to factor here. This x minus 2 can't be simplified, this 3 can't be simplified. So we do what we did when we were adding and subtracting our fractions. After we factor everything that we possibly can, we circle our different factors. So the first factor I see that I'm circling is x minus 2. The next thing I'm circling is the 3. The third x denominator that I'm seeing is x minus 2, which I already have circled, so I don't have to circle it again. Now I take all the circled denominators, which is the 3 and the x minus 2, and put it over 1. My common denominator is, I usually put, you could have put x minus 2 and then the 3 afterwards, but somehow it just looks more familiar when we put the monomial first and the binomial second. I'm going to use this to multiply through the whole equation. And I know it takes a lot of writing, but if you write it and you give yourself space, you're more likely to get the problem right than if you try to do too much in your head. Remember, again, we have to distribute this common denominator to each of the terms. So I'm going to have the 3 times x minus 2 over 1 times x over x minus 2 plus the 3 over x times x minus 2 over 1. I'm taking this times the 2/3 times 2 over 3. And finally, I'm going to do that same 3 times x minus 2 over 1. And I'm going to put it next to or multiply by the 2 over the x minus 2. So I'm taking this LCD and multiplying it by each of the terms. Now remember what I said, when you do this, the next step should make sure that each of your denominators turn out to be equal to 1. Over here, the x minus 2 is going to cancel out with the x minus 2. That'll leave me a 1 here. And all I'm left with in the numerator is a 3 times x, which is 3x. Now 3x, the denominator is obviously 1, so I don't have to put it in. Going on to my next fraction. Here, the 3 cancels out with this 3, and I end up with the x minus 2 times 2. Like, we could put the 2 in front. And finally, on the other side of the equal sign, the x minus 2 here cancels out with the x minus 2. Do you notice how each of the denominators are now only 1, so I don't have to put them in? And what I'm left with here is just 3 times 2, which is 6. And this is a relatively easy equation to solve. We get 3x, I'm removing this parenthesis, so that's giving me plus 2x minus 4 equals 6. The 3x and the 2x give me 5x. And the minus 4 I'm going to bring to the other side. So that's going to give me 6 and 4, which is 10. And then I just have to divide by 5 to get my final answer that x equals 2. Did everybody follow that? Are there any questions? Okay, and I want to show you something interesting. Something that we really have to be aware of. I haven't been I've been a little bit neglectful, let's put it that way. Usually when we solve an equation, we get an answer and we check our equation. We check, did we do it right? How do we check an equation? We stick the answer that we got into the value of x and then see if it works. Most of the time we assume our answers are going to work and we don't take the time to check. I want to show you what happens in this case when we check. I'm going to do the check right over here. Remember, my answer is 2. So this is my solution. I'm going to put in 2 into my equation. So here's my original equation. Wherever I see an x, I'm putting a 2. So I'm getting 2 over 2 minus 2 plus 2 over 3 equals 2 over, again, my x is 2, 2 minus 2. Now look what's happening. 2 minus 2 gives me 0, so I'm getting 2 over 0 plus 2/3 equals 2 over 0. And actually, as soon as I got to this, as I would have noticed it here also, as soon as I got to a situation where I had a 0 in the denominator, I knew I was in trouble. Because the one operation you're never allowed to do in mathematics is to try and divide by 0. You cannot have a 0 in a denominator. We use the term undefined, but really it means you can't do it. It doesn't exist, it's not allowed. So if my answer were 2, it really gave me a situation that is unsustainable. It doesn't work. This is what's called an extraneous root. The word extraneous happens to be an English word. It's not a mathematical word. What it means is something that's extra. You see that word extra in it, but it's extra and you don't want it. Sometimes you get something that you weren't really counting on. It's extra and you like it, so it's a bonus. But something that's extraneous is not a bonus. It's something we don't want. And that can happen in these type of rational equations. And what causes that to happen? It happens when your solution that you get makes your denominator equal to 0. And it can be, and there could be 10 denominators and none of them are good. If one of them turns out to be 0, you cannot use that answer. In other words, this answer has to be thrown out. There is no solution here. Don't write the answer x equals 2 extraneous. No, the answer is there is no answer. Because the only answer that we got, this x equal to 2, and we did all the correct work. It wasn't that we made a mistake. It gave us something that made a denominator equal to 0, and therefore it can't be used. In other words, we can write the word no solution. You could write it with a 0 with a line through it that also means no solution, or you could write it with a brackets with nothing in it. That's also another way of writing no solution. But essentially what we're saying is this equation has no solution. So let's see how this affects us. We know now how to solve rational equations. We have to find a common denominator and multiply everything through by the common denominator. Once we've done that and we've solved our equation, we must, it's not optional, we must make sure that the answer we got is not extraneous. The best thing would be to check the whole equation. But if you're running low on time and you just want to make sure that it's not extraneous, take your answer and stick it into the denominators. Notice if I put x for 2 in this denominator, I got 2 minus 2 and I got 0. If any of your denominators turn out to be 0, you have to not accept that answer. You have to throw out that answer. It's not an acceptable answer. If it turned out that there was only one answer, which is what we got over here, then there's no solution. Occasionally, you get 2 answers to your equation, and one of them works, one of them is extraneous. Then throw out the extraneous root and just accept the one that works. Okay, so that's where we're at. I want to give you a problem to try on your own. I'm going to give you a few minutes. I'm going to give you a good 5 minutes to try this. But remember, once you finish, you have to check that your answers are not extraneous. Now, you're going to ask me, why didn't I do it before? I really was doing it before. I just didn't see a point of trying to indicate something where I knew it wasn't going to really, you wouldn't affect you. So you really always have to check that you do not have an extraneous root when you're dealing with fractions in your equations. Okay, I'm going to erase this and I'm going to give you one to try. And a little hint, very often they give you these type of questions where they throw in the trick that it does have an extraneous root. You really have to be aware of it and check it out, because you could do everything correctly, like I did at the end, and get x equals 2. And x equals 2 is not a correct answer. Okay, here's the one I want you to try. 2 over x minus 3 plus 1 over x equals 1 over 2x squared minus 6x. Remember, your first step is going to be to find your common denominator, and then the next step is to multiply all your terms in your equation by that common denominator. While you are doing that problem, I'm going to take attendance. Okay, Jesus, I know you're here because you keep me posted. It's 10:21. Jackson Avila. Hi, Jackson. Tiffany.
I'm here.
Were you here on Tuesday?
No.
Oh, okay, so I just wanted to make sure I was not wrong, okay. All right, you told me you were. Kayla Brantley. Hi, Kayla. Tashana Caesar. Tashana? Dion, I know you're here because we talked. Wensley Charlemagne. Wensley. Tatiana Collins. Hi, Tatiana. Awa Diallo. Hi. Ashay Douglas. Hi, good morning. Eliana Estee. Eliana, hi, Eliana. Emily Gomez. Emily Gomez. Anastasia Guerra. Anastasia. Zenabu. Zenabu Hamed. Ismail.
Here, but I'm gonna need to step away for a minute.
Oh, yeah, it's fine. I know you're always here. I know my regulars.
Okay,
Jaden.
thank you.
You'll see that some people I just don't, I go on to the next, and some people I wait, and that has to do with if I expect you to answer or not. Jaden here, Jaden Jackson, Ashiana Jacobs. Hi, Ashiana. Anijah John. Thomas John. Okay, Tashana, thank you. I see you're here.
I'm here. Thomas John.
Yeah, I got you, Thomas. Paul LeBrun.
I'm here.
Good. Ashley Moorhead. Ashley.
Here.
Hi.
Hi.
Angelica, I know you're here because I spoke to you earlier. Tayan, I'm pretty sure I saw your name. Hi, Tayan. Akeem,
I'm here.
yeah, I count on you being here. Craig Ricketts. Giovanni Rowe. Hi, Giovanni. Devonley here. And the J. Waddell. Something's wrong because I only have 18 people and I should have. Okay, Jaden, I didn't see that you didn't answer, but I see you're here. Okay. Got it correct now. And I see a couple of people have already given me answers. Let's see if we can do this and get an answer. Okay, so we're going to do this problem now. And of course, the first thing we want to do is find the common denominator, which means since I see polynomials in my denominator, I have to factor my denominators. This is x minus 3, this is an x. So there's nothing to factor here. But this 2x squared minus 6x, I can factor, I have a common factor of 2x, it becomes 2x and x minus 3. And then what we do, remember, we go and we circle all our different factors that we see. So in the first fraction, we have an x minus 3. In the second fraction, we have an x. That's different. In the third fraction, the factors I have are a 2. Now, I don't see a 2 anywhere here, so I better do the 2. An x, which I already have, and an x minus 3 that I already have. So my common denominator turns out to be 2x times x minus 3. Now, I don't have to put the 2 and the x in parentheses, even though they are factors, because they're monomials, but they are factors. Now, I'm going to take this 2x times x minus 3 and multiply it by the whole equation. Now, I'm just going to right away distribute it rather than rewriting this. So I'm going to multiply this by the 2 over x minus 3. I'm then going to do 2x times x minus 3 over 1 times 1 over x. And that has to equal the 2x times x minus 3 over 1 times 1 over 2x times x minus 3. Okay. So I took this common denominator, which is pretty big, put it over 1, and distributed, multiplied it by each one of these fractions. Now, I'm gonna simplify it. Remember, when I do that, the denominator should turn out to be 1. That's the whole point of this. Well, in this case, the x minus 3 cancels out with this x minus 3. This leaves me 1. And all I'm left with is the 2x times 2. I'm not even going to multiply it. I'm just going to write it out, though I could have right away said 4x. I'm just writing what I'm left with. Okay, now we have a plus. And over here, the x here cancels out with this 2x over here, and it leaves me the 2 times x minus 3. The x is gone now, times the 1. It's over here. And finally, here, the whole 2x minus 3 cancels out with this whole 2x minus 3. The whole thing canceled out. Remember, when everything cancels out, it could have 1. So I'm left with 1 times 1. Of course, just written it as 1. And here we have our very simple equation to solve. 2x times 2 is 4x. 2 times x minus 3 is 2x minus 6. And that equals 1. So I combine the 4x and the 2x, that gives me 6x. I add 6 to both sides. That'll give me 7. And then I divide by 6. So my final answer comes out to be 7 over 6. Don't be surprised if you get an answer that is a fraction. No, this is clear that this is 7 over 6. Your answer turned out to be 7 over 6. What I really have to do is check that this is not an extraneous root. And sticking in for x, 7 over 6 is not so easy. But remember, all I have to make sure is that it doesn't make a denominator equal to 0. Now, if I had 7 over 6 minus 3, obviously that's not going to be 0. The only thing that will give me 0 would be a 3. This is certainly 7 over 6 is not 0, so that's okay. And this is okay, and this is okay, and this is okay. It's not making any denominator equal to 0. So if I did the right work, and I'm pretty sure I did, this is my solution. It's not an extraneous root. It worked out. This is about as hard an example as you could get. Solving rational equations. Don't forget that you have to make sure that you do not have an extraneous root. Okay, before I go on to a new topic, I want to make sure, does anybody have anything that they want to ask me in regards to the midterm? Okay, if not, then I'm going to go on to a new topic, which is really still part of chapter 5. This is the last topic in chapter 5.
Wait, hold on. Don't.
Okay,
Hold on. 1 second.
okay, got it.
Let me just take a quick picture then. Okay, you can erase it.
Can I erase it yet?
Yeah, you can erase it.
Okay, great, thank you. And, okay, thank you, Tiffany. I'm glad when somebody stops me because I'm never sure if I assume if nobody says anything that I can go on. Okay, so don't forget, stop me, even if it, or you can do it with a chat. We're gonna be talking about dividing monomials, and really, well, we talked about dividing monomials. We're going to be talking about dividing polynomials. Between chapters 4 and 5, we have talked about adding, subtracting, multiplying, and now dividing polynomials, and factoring polynomials, and working with what we call rational expressions, fractions. Now, fractions is a kind of division. That's why they put them sort of in the same chapter. So let's talk about first, what happens if I want to divide a polynomial by a monomial. Let's say I have something like this. I have 10x to the third no, it's not, it's 10x to the fifth. That's right. Ten x to the fifth minus 15x to the fourth plus 5x squared. I have that polynomial and it's over 5x squared. And what we're told to do with this is to divide. They want me to divide the polynomial, which is on top, it happens to be a trinomial because there are 3 terms, by the monomial 5x squared. And when the term is divided, it didn't say simplify, it said divide. What you want to do with this is take each of the terms in the numerator and separately put it over the denominator. In other words, rewrite this as 10x to the fifth over 5x squared minus 15x to the fourth over 5x squared plus 5x squared over 5x squared. When you are dividing a polynomial by a monomial, you want to divide every single term by the divisor, by the denominator. That's what you're dividing by. We're indicating division by using a fraction because that's what a fraction really means. And then you take each of one of these fractions and you simplify them, you reduce them, which we've done before. Remember, these are all monomials now. So with a 10 over the 5, I can cancel that out. This will give me a 2, this will give me a 1. The x fifth divided by the x squared. Remember, we cancel out the lower exponent, which in this case is x squared, so I better put a 1 over here. And I subtract it from the higher exponent. So 5 minus 2 is 3. So that gives me 2x to the third as my first term. Notice it's over 1. When the 1 is in the denominator, you do not have to put it in. If the 1 is on top, you have to put it in, but in the denominator, you don't. You then go to your second fraction, do the same thing. Here, the 15 cancels out with a 5, and this leaves me a 3 on top. And the x squared and the x fourth, again, the lower exponent is the x squared, so that gives me a 1 on the bottom. And 4 minus 2 is 2, so this gives me x squared. So my next term is negative 3x squared. And finally, here the 5 cancels out with a 5. The x squared cancels out with the x squared. I'm left with 1 over 1, which is just 1. Don't make the mistake of, if something totally cancels out, just not to put it in. My original, the numerator had 3 terms. It was a trinomial. My answer has to be a trinomial as well. I can't, just because these are both the same thing, they cancel out, but we're left with 1. And this would be your answer for this problem. sometimes you're still left with fractions. You know, sometimes the fractions, sometimes you don't always get all the denominators equal to 1. But this is basically the way you divide a polynomial by a monomial. Okay, let's see if I can give you one to try. Is it okay if I erase it? Okay. Here's one for you to do. 15a third b plus 30 a squared b squared plus 20 ab cubed. That's my numerator. My denominator is 15 a squared b squared. And again, I want you to divide this and the way we just did this other problem. Give you a few minutes to try it. Okay, I think everybody had enough time trying this. Let's see if we can do it together. Again, as we did before, we're going to take each one of these terms and put it over the denominator. So we're going to have our 15a3b over 15 a squared b squared plus the 30 a squared b squared over the 15 a squared b squared plus the 20 ab to the third over the 15 a squared b squared. The hardest part is to rewrite it. There's just so much writing. Okay, now we go look at each of these fractions separately. So here are 15 on top with a 15 on the bottom. These are all monomials, so I can just take them piece by piece. The 15s cancel out. Then I look at the a's. I have an a squared and an a cubed. Now remember, I always cross out the one with the lower exponent and I subtract it. 3 minus 2 is 1. That gives me a to the 1, which is just an a, and it's on top. It always ends up where the higher exponent was. Then I look at the b's. I have a b on top and a b squared on the bottom. So the b, which is just b to the 1, is the one that we cross out. And we do 2 minus 1, which is 1. So this just gives me b to the 1 or b. And notice that's in the denominator. So my first fraction became a over b. Be very careful that you keep the numbers and the letters in the right position. The lower exponent gets crossed out and the answer remains where the higher exponent is. Okay, we're going to do the next fraction. So we have a 30 on top and a 15 on the bottom. The 15 cancels out and 15 into 30 gives me 2. Then we look at the letters. A squared over a squared, that just cancels out. And b squared over b squared just cancels out. So I'm left with 2 over 1. Since my denominator is 1, I could just write 2. And finally, we have the last fraction. I have a 20 on top and a 15 on the bottom. The number that goes into both of them is 5. So 15 divided by 5 is 3. 20 divided by 5 is 4. Again, the letters. The variable a. This is the lower exponent. 2 minus 1 is 1. So I get an a on the bottom. And the b cubed to the b squared, the lower one is the b squared, so that gets crossed out. 3 minus 2 is 1, so I'm left with this in that one with a b on top. So the last fraction becomes 4b over 3a. Now it is a lot simpler than what we started out with. This is the answer that you want to get when you are dividing. So that's how we divide a polynomial by a monomial. I'm sorry. We divided a polynomial by a monomial. Is there any questions about this? Okay. So then we're going to go on to the next step.
I was going to say, can we try one more?
Can we try one more? Okay. We can do another one.
If we have,
Yeah. If we have. Yeah, and what was, yeah, you were saying something, but I lost you. Okay.
yeah, I said if we have the time.
Well, you know what? Let's, did you understand it basically? Or are you not sure about it?
Yeah, I did. I did understand it, but I did make a mistake at the end with the crossing out of the A's.
Okay, do you understand what
So
you
I ended up with 3AB. I forgot to put it at the top instead of
Okay, so that's the only thing you have to remember, that the answer always comes out where the larger exponent was. If you look at it, here the b was a larger exponent, so we were left with the b on top. Here the a, there was an a and an a squared. The a was squared was a larger exponent, so that's why the a had to be on the bottom. Just keep that in mind. You always, that's your check, that you're left with your variable where the larger exponent was. Okay, so I really would like to go on to the next topic because it is something that takes a bit of time and it takes a little bit of digesting, I guess is what I want. So I'm going to teach it now and I'm going to reteach it on Tuesday. Again, this is not part of the midterm, but it certainly is on the final. And that is, how do you divide a polynomial by a binomial? what if your divisor, the thing that's on the bottom, is not a single term? What if it's a binomial? So let's say I have this problem. I want to divide 2x squared minus 7x plus 9, which is a trinomial, by the binomial x minus 2. Now, I'm going to show you something that's called long division. There is another method that sometimes can be used with dividing polynomials. It's called synthetic division. I don't teach it here. I teach what's called long division. And long division, I'm going to just remind you the steps involved in regular long division, because we're going to see long division of polynomials are the same steps. So let's say I had told you that I wanted to divide 25 into, what do they have? 4,628. Now, nowadays, of course, when we have just division of numbers, we just pull out our calculators and do it with our calculators. But let's see if we can remember the steps you learned in elementary school to do this division. If you remember what you do, you say, well, 25 doesn't go into 4, so I have to take the 25 and divide it into the 46. So I know 25 goes into 46 one time, because if I was 2, it would be 50. And I put a 1 on top. And the one I put on top is on top of the 6, because I have to keep the position very proper. Once I've done the division, and I sort of guess at what I should put on top, I take that number that I put on top and multiply it by the divisor. So 1 times 25 is 25. I bring it and I put it right under my, what we call dividend, the thing that's inside the divisor, the division sign. And after I have multiplied, I subtract. I do 6 minus 5 is 1, 4 minus 2 is 2. So remember what we did. We divided, then we multiplied, then we subtracted. And the next step is to bring down the next number. Now, the next number I see is a 2. And if this was more than 25, then I would have known I'd have to start over again. But usually this remainder that we got has to be less than the divisor. So we bring down the next number, and again, now we start the process again. We take the 25 and divide it into 212. Now 25 into 200 goes, I think, 8 times. I think 8 would work. I put the 8 on the top, so I divide it. The next step is to multiply. I'm going to take what I just put on top, the 8, just the 8 part, and multiply it by the 25. So 8 times 5 is 40. And 8 times 2 is 16. 16 and 4 is 200. And I divided, I multiplied, so now I'm subtracted. Now 212 minus 200 gives me 12. And now I bring down the next number, which is 8. And again, repeat the process. 25 divided into 125. I think 5 might work. So I'll only know if I'm doing it right. When I multiply, it's more than this, I have to make this number less. If when I multiply this and I subtract, I get more than 25, I know I have to go up on that. So it's always a guess. It's a guessing game here. So I try the 5 times 5, that gives me 25. And 5 times 2 is 10, and I have that 2 from before, so that gives me 12. So I get 5 times 25 is 125. I now subtract and I get 3. Now, one thing you could have done at that point is to put a decimal point and bring down a next number. But the type of division we're going to do is not division with getting and going out and getting a decimal answer. What we want to do is what's called division with remainder. When nothing else is left, there are no more things that we can bring down. My remainder is the answer over here. I have a remainder of 3. In other words, my answer was 185, remainder 3. What we usually do with the remainder is we put it over the divisor and we write it 185 plus 3 over 25. That's another way of writing it. When it's just regular numbers, you could have just write it 185 and 3/25. When you have numbers, just numbers, if you have a fraction next to a number, it means that you're adding that fraction. That's not what we do with variables, because when we have one next to the other, it means multiplication. So those are the basic steps that we have to use to divide. Let me just write them down. Step 1 was to divide. I'm just using symbols. Step 2 was to multiply. We multiply what we put on top by the divisor. Step 3 is to subtract. You put it underneath the dividend and you subtract. And step 4 is to bring down the next term and start the process all over again. Okay, that is the steps of long division. That's nothing new to you. You did it a long time ago, maybe, but you did learn how to do this. Let me show you how to apply this to division of polynomials. We do this when we have a polynomial, which we do on top. It happens to be a trinomial. And my divisor, in other words, the denominator, is also a polynomial. You only have to worry about the divisor being a binomial, but this process could be even if this is a trinomial or more terms. And again, the instructions say divide. They want us to do long division. So step 1 is to rewrite the problem like a regular division. In other words, put the x minus 2 on the outside. Remember, the denominator is the divisor. And the 2x squared minus 7x plus 9 is what we call the dividend, what we're dividing into. What we have to be sure about is that my terms are in what we call descending order. Descending order means the highest power, next highest power, until we only have plain numbers. Descending order. That's very important, that things should be in order. What we do is we want to divide the x minus 2 into this thing. But it's very hard to divide by x minus 2. And since all I'm doing is trying to guess what to put on top, when I'm going to divide just by the first term, just by the x in this case, which is a 1x. Dividing by 1x is not so hard. If I want to divide 1x into 2x squared, well, the 1 will go into the 2 and give me 2. And the x will go into the x squared and give me x. X goes into 2x squared, 2x times. It doesn't matter where you put the answer you just got on top. Whereas with numbers, positioning is very important. Here, it doesn't matter. You can put it over the x squared terms, you can put it over the x term, it doesn't matter. Okay, so we just did the divide part. Divide just the x into the 2x squared and put your answer on top. What's our next step? Next step is multiplication. Take what you just put on top, which is a 2x, and multiply your divisor by it. Now, when you're doing the multiplication, you have to multiply by both terms. In other words, you multiply the 2x times 2x, the 2x times x, and that gives you 2x squared. And you also multiply the 2x times -2, and you get -4x. Since you have things in descending order, the terms are going to come out right under each other. Okay, so we did the multiplication, so the next step is to subtract. Now I'm going to do subtraction the way we've done it with polynomials. One of the ways to do subtraction is to change your sign. This is going to become a negative because it was originally a positive 2x squared, and this negative is going to become a positive. I do this, or you could do it in your head. You could do 2x squared minus 2x squared. But don't forget, when you're doing -7x, it's minus -4x. That's why it's better to first change the sign. Then you'll have everything. You just have to work it. 2x squared minus 2x squared cancels. -7x plus 4x gives me -3x. So be careful with the subtraction. Okay, after we subtract, the next thing is to bring down the next term, which happens to be the 9. And now we start the process again. We take only our first term. When we're doing the dividing, we only divide by the first term. The 1x into the -3x. Well, the x's are going to cancel out, and what I'm going to be left with is -3. I'm not subtracting, I'm dividing. The x's cancel out, I'm left with -3. Okay, I take what I just put on top, which is the -3, and multiply it by the whole divisor. So -3 times x gives me -3x. And -3 times -2 gives me +6. You're going to have to be careful with your signs. And now we want to subtract. So this is going to become a plus, and this is going to become a minus, because we're changing the signs to subtract. So now we have a -3x and a +3x, which cancels, and a 9 minus 6, which gives me +3. There's nothing left to bring down, so this is my remainder. And how do we write our answer? We take what we put on top, the 2x minus 3, and do +3 over my divisor, which is x minus 2. That's one way to write it, or another way to write it is to write my answer, my quotient, that's the answer from division, is 2x minus 3, and I have a remainder of 3. Mostly we take the remainder and put it over the divisor. Okay. I'm not going to give you any of these to try for your own yet, and I'm not even going to give this as part of your homework. Though there is going to be homework, it's going to be on the rational equations. What I am going to do is I have a few minutes. I want to do one more problem like this so you get an idea of how to do this. Let's do one more problem. Okay, can I erase this? I'm just going to read the instructions. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. I have this question. Six x squared plus 7x minus 18 divided by 3x minus 4. Again, we have a trinomial that we're dividing by a binomial. When we're dividing by a binomial, we have to use this long division. We rewrite it as 3x minus 4 on the outside. And inside my division sign, I'm going to put the dividend 6x squared plus 7x minus 18. Remember, the 3x minus 4, is called either the divisor or the denominator. The numerator is also called the dividend. We write it like a long division. And we're going to take, and again, it's got to say divide. It's not saying reduce or simplify, just say divide. So we have to do this process. We take the first term, which is 3x, and divide it into the 6x squared. So 3 divides into 6, and that gives me 2. And the x divides into the x squared and gives me x to the 1, or just x. So 3x into 6x squared is 2x. We divide, now we multiply. We take the 2x, what we just put on top, and multiply it by both terms of my binomial. 2x times 3x is 6x squared. 2x times negative 4 is negative 8x. Now I've done the multiplication, now I want to do the subtraction. Now remember, I always like to do the subtraction by changing signs and then combining. So this is originally a positive, it's going to become a negative. And this is originally a negative, so it's going to become a positive. I do something wrong. Oh, I'm sorry. I did do something wrong. This is not a 17. This is supposed to be a 7. Well, it doesn't change too much now. I just knew I was doing something wrong. By the results, it was coming out to be a much too hard problem. Okay, this is not to be a 17x, it's supposed to be a 7. But everything, well, nothing, it didn't affect anything. Okay, so now we're doing 6x squared minus 6x squared, and that's canceling out. And now I have a positive 7x, and this is now a positive 8x because I've changed its sign, so that's becoming a 15x. And I bring down the next term. And now I start the process again. I take my 3x part, just the first term, and divide it into the first term here. 3 into 15 gives me 5. The x into the x cancels out. Remember, if everything cancels out, then you have to put a 1 there. It's not, you don't leave it blank, you put a number there. In this case, we divided 3x into 15x and got 5. Okay, we did the division, now we're up to the multiplication. We take what we just put on top, which is the 5, and multiply by both terms. 5 times 3x is 15x. 5 times -4 is -20. So now we have to do our subtraction, and again, I'm going to change my signs. This is a positive 15x, so it's becoming a negative. This is a -20, so it's becoming a positive 20. 15x and -15x cancel out. -18 plus 20 gives me +2. My remainder is +2. There's nothing more to bring down. So my answer comes out to be 2x plus 5 plus the 2 over the 3x minus 4. Or again, alternatively, you could have said the quotient is 2x plus 5 and the remainder is 2. Okay, I'm going to stop right here. Reminder. Don't forget about the midterm. You have starting today at 2 o'clock until 4 o'clock on Friday. Set aside a 75-minute period of time that you can sit. You cannot start it and stop in the middle. Once you start, once the timer starts, it'll run out after 75 minutes and it will automatically submit your exam. Or if you start and then you close your computer, it will automatically submit your exam. If you have any technical difficulties, your internet went down, your device that you're working on somehow closed, or sometimes just you push the wrong button. If it closes before, send me an email so I can reset the test, but don't, keep in mind that it's not really something you want to happen because you get a whole new test, all that you have to start from scratch. I will give you the full amount of time. In other words, if you have to restart, I won't give you just the remaining time that you had, you will get your full 75 minutes. Okay, good luck on the test and have a good weekend. Look out for homework on Delta Math. That'll be due for Tuesday. I'm probably going to post it first tomorrow. Any questions?
No questions. Professor, have a great weekend.
You too. So I hope you're so happy with how your test is that you're going to have a great weekend.
Yes, I am. Thank you.
Okay, everybody have a good weekend and
Have a good weekend.
thank you. Bye-bye.
Bye.
Bye, Shireen. Okay.